The next thing we're going to cover are type predicates. Now, I think this is probably the one topic in this section that is a little bit more challenging or complex than anything else. So far, we've seen how we can narrow the type using, instance of or type of or things that exist in JavaScript. No new syntax, no new features. This video and type predicates are a feature specific to TypeScript, and it takes a couple of steps to explain. But essentially, we can define a function, a custom function like isCat or is user, is admin. They don't have to be named that, but that's usually what we would call them, is something. And then they can tell TypeScript whether a value is of a particular type. They actually can tell TypeScript the type of something. So let me show you what I mean. Let's say we have two simple interfaces. Let's go with cat and dog. So a cat has a name that's a string, and then num lives, that's a number. All right, and then we've got another interface, dog, that also has a name that's a string, and then a breed, that's a string. Okay, and then I write some function called make noise, and it's going to just return meow for a cat and return woof for a dog. So it's going to accept an animal of type cat, or dog. And then it will return a string. Okay? So then in here, how do I know if it's a cat or a dog? There's different ways, right? We could use the in operator. But what I want to do in this video is actually make a reusable function that I could use all over the place. Let's call it isCat. So this function isCat is going to return true or false, and it will tell us whether some value that's passed in, right, some animal, is a cat or not. So how are we going to do that? How do we check if something is a cat or not? Well, one way is just to check to see if it has num lives, and if that's not equal to undefined. There's different options here, but here's a really common pattern for these types of functions. Animal as, and then we cast it to a cat, or we assert that it's a cat, and then we check if num lives is not equal to undefined, and we return that. Okay, and then here, it's going to complain that I said animal has any type, so I could say it's explicitly any type, which is fine, or I can say it's of cat or dog. It doesn't matter, it's just how I'm going to use this function in the future. All right, so now I have this function isCat, and it's going to return true or false, basically whether the animal that's passed in has a num lives property. If it does have num lives, it's not undefined, then it's true, right? We know it's a cat. Otherwise, it will be a dog. Okay, so this is not quite going to work to narrow the type. This will work for us as humans to know if something is a cat. And here I can do if isCat animal, well then I will return meow. Great. But if we look at what animal is right here, it's still cat or dog. TypeScript doesn't know that this narrows the type in any way. It's just some function that returns true or false. It has no way of connecting that to the fact that we are trying to narrow the type. We're trying to determine that animal actually is a cat. So this is the new trickier part. We use what's called a type predicate, and it's a very particular syntax, and it must be the return type of this function. It follows this format. Parameter name is type. So in my example here, isCat, I use this parameter name, so animal, is cat. And this tells TypeScript right here, this says, if this function returns true, then we know the value that was passed in is of type cat. Otherwise, we don't know that it's a cat. It's not a cat. So now I'm connecting the logic of this function to a narrowing of a type in TypeScript. So this will go away in JavaScript, right? That's not valid JavaScript, of course. Neither is as. But anyway, this is the key piece that tells TypeScript that this function actually determines if something is a cat or not. So now down here, if I look at animal, inside this conditional is cat, now animal is a cat. And then if I have an else, and I look at animal, It's a dog. So this function tells TypeScript, it returns whether this thing is a cat or not. If I get rid of this piece, now it's a function that tells us as humans if it's a cat or a dog, if animal is well, it says if it's a cat, it doesn't say if it's a dog. Anyway, it will tell us if animal is a cat, but TypeScript doesn't know that. So it still thinks, here it could be a cat or a dog. Here it could be a cat or a dog. But as soon as I say, hello TypeScript, this special function is going to tell you whether the animal that's passed in is a cat, now it knows. And it says, all right, that is a cat if we make it into this conditional. Down here, it's a dog. So the syntax, once again, this must be the return type. Animal is cat. Animal must match the name of this parameter. So if this is something else, you just change that. They are connected. It's how TypeScript knows whatever you pass in is of some type. And then your function must return a Boolean, true or false. You don't have to name it is cat, but I don't know what else you would name it. It's the best choice, but TypeScript doesn't care about the name. So that's the concept of a type predicate. It's a little tricky, as I mentioned. It's now a reusable function that we have. This part is the type predicate, not the whole function. Terminology doesn't really matter though. But this is a predicate, and we have a reusable function, and we can make these for all sorts of different types if we were trying to narrow the type all the time and trying to determine if something is a user, if it's an admin, if it's whatever. We can then create these special functions.